Very good morning to one and all present here. Very good morning to all the dignitaries, to all the professors, colleagues, and my dear friends present here. Myself, Dr. Ramya Ramkumar. I am working currently at Yangnam University at the Department of Chemical Engineering under Professor Woo Kyung Kim. And the topic of my presentation for today is going to be synthesis, characterization, and fabrication of nickel oxide nanoflake aerogels as anodes for asymmetric supercapacitors. So I have organized my presentation in the following manner. I will give you a brief introduction about aerogels and the materials and methods used for the synthesis, characterization of our aerogels, and some of the electrochemical results, and the device fabrication, summary, and reference and acknowledgements. So as you all know what aerogels, to the left is actually a gold aerogel, which is actually a gold solution which turns into aerogel at the time frame of 6 hours. And that is the schematic of how this reaction happens. So there can be two methods of synthesis of these aerogels. One is a single one-pot synthesis, which we call it as a single set synthesis, which is a direct reduction of the gold into gold nanoparticles and subsequent formation of sol and the final gel. And there is another method wherein it takes place under two steps. So first reduction of the nanoparticles and then the formation of sol gel and finally aerogels. So this is a typical schematic of how these aerogels are formed, wherein we can see that the nanoparticles undergo reduction and then there is actually accumulation and they form into sols and subsequent hydrogen evolution takes place. So the aerogel or the hydrogel floats to the top, and then after the hydrogen evolution stops, the final aerogel settles to the bottom. So this is another example of palladium hydrogel formation, and after drying, so these aerogels when they are actually forming in the solution, they are called as hydrogel if the medium is water, and if the medium is alcohol, they are called alcogels. So these gels have to be dried by various techniques, and some of the interesting techniques used for drying them are vacuum drying, organic solvent sublimation drying, freeze drying, and supercritical carbon dioxide drying. Out of these drying methods, what I have used for my synthesis is freeze drying method. So after the drying process, the aerogel looks like somewhat like this. So mostly the transition elements and the precious elements, they form aerogels, and the final product looks like this. And this is again another schematic, and to the right, as we all know, is the famous silica aerogel. So silica, carbon, and some of the organic aerogels looks like this, irrespective, unlike the other counterparts, the metal aerogels. And as we can see, there is a block of silica aerogel here, and it can hold up to 1,000 times its weight. So that is a property of these aerogels. And they are very light in weight, so they also hold the Guinness World Record of being the lightest known solid to humans. It weighs only 3 milligrams, whereas the actual solid known to humans weighs around some 6 grams. And this is another property of these silica aerogels, wherein they can actually thermally insulating up to various temperatures. And they have very interesting properties. They have nanostructured porous structures, and they actually can be made very simply by using sol gel technology. And it was invented by Samuel Kistler in 1931. And as I already told you, they can withstand more weight, than 1,000 times more weight than their own weight. And some of the interesting aerogels that have been synthesized until now include some oxides, polymers, and then some carbon, and then some organics. So these are some of the introduction to aerogels. So some of the materials and methods used in our synthesis include nickel salts as a precursors, and some of the reducing agents for reducing these salts, and some of the solvents. And the as formed aerogels were annealed at different temperatures to see their performance in energy studies, and electrochemical studies were also carried out at various electrolytes, and the preferable electrolytes was found to be potassium hydroxide. And the reference electrode for electrochemical measurements were silver chloride, and the counter electrode was fixed to be platinum foil. This is again another schematic to show more clearly the formation of the network-like aerogel structures. So we characterized our nickel aerogels, and we found that the as synthesized nickel aerogels were found to be nothing but alpha nickel hydroxide aerogels, and this was confirmed using the FTIR peaks. And when we annealed the samples to 400 degree, we found that these can be converted into nickel oxide and nickel aerogels, and this was also confirmed with the FDR studies. Further, we went on to characterize the same using XRD studies, and we found from the peaks positions that this also confirms the presence of alpha nickel hydroxide, and when the annealed sample, it confirms the presence of nickel oxide and nickel. So these are actually confirmed from these two studies. We further went on to do some BET measurements, and we found that there is not much of a difference when it comes to the as synthesized and the annealed samples. And this is some of the values for BET, which is around 55 meters squared per gram. And we found that it also contains some meso and micropores. So next we went on to characterize the same nickel as synthesized nickel hydroxide with SEM and TEM studies and some SAED patterns, and we found that it exhibited very nice porous and a nanoflaky morphology, which is actually a preferable candidate for energy applications. And when we see that this is the SEM for the annealed samples at 400 degree, and we see that the structural integrity is still maintained after the annealing. And we see the patterns in the TEM also confirms the same. So then we went on to characterize this material for energy application using a 3-electrode study for supercapacitor using cyclic voltammetry. So we compared the as synthesized aerogel and the annealed sample. So there is a good amount of difference when we see the cyclic voltammetry. This is at 25 millivolt per second scan rate. So we went on to do at other scan rates for the annealed samples from 2 to 50 millivolt per second. So this also confirms the good activity of this material. So next we carried out the charge discharge studies, and we found that at various current densities the material behaved in a good manner. And also we did some impedance studies to see the property of the material, and this black line shows the as synthesized nickel hydroxide, and this red line shows the nickel oxide. So where we can see that the reduced impedance means actually a good conductance and also good capacitive properties. And finally we calculated specific capacitance versus current density for this as synthesized as well as the annealed sample, and we found that the annealed sample exhibits almost 1100 farad per gram of specific capacitance. So these are some of the values which are inferred from the cyclic voltammetric, charge discharge and impedance studies. Next we went on to fabricate a device using this nickel annealed sample, nickel oxide and nickel as the positive electrode, and the negative electrode was chosen to be the traditional activated carbon. So we saw that the charge discharge and the cyclic voltammetry were giving fairly good results, and also the EIS did not increase much, showing also the good activity of the material. So we finally plotted the Ragun plot and compared it with other materials in literature, and we saw that our material was performing way ahead of all the materials, and there is no additives in terms of our materials, whereas the literature available materials have to be added with something or the other to enhance the performance. So these are again some of the values which are inferred from the measurements. And the energy density was almost 32.4 watt-hour per kilogram, and the power density was calculated to be 1800 watt per kilogram. So having done this, to summarize and conclude my results, we synthesized alpha nickel hydroxide and then annealed those aerogels to form nickel oxide using a one-pot sol-gel synthesis. These were characterized using various techniques of FTR, XRD, SEMTEM and BET measurements for analyzing the physico-chemical and morphological properties. Electrochemical measurements were measured using cyclic voltammetry, charge discharge and impedance measurements. We found that the activity of nickel oxide aerogels were studied for energy storage device with supercapacitor applications. And finally, because the application was good in the 3-electrode, we chosen this material and fabricated a 2-electrode device with nickel oxide as positive electrode and AC as a negative electrode for the capacitor. So I would like to thank also the Korean Society of Chemical Engineering for organizing this conference and giving me this opportunity to present my work. And this work was actually supported by the National Research Foundation of Korea and Ministry of Education, and also Clean Energy Priority Research Center at Yangnam University, and my lab, which is Thin Film Photovoltaic Materials Laboratory. And these are some of the references that I have used. And thank you so much.
혹시 질문 있으십니까?
I would like to ask why you choose nickel for the supercapacitor. And another question is, have you checked the volumetric specific capacitance? Because nowadays volumetric capacitance is very important.
Yes, Professor. So we actually started synthesizing aerogels using copper, and we found that copper was actually a very good material to be synthesized instantly. So we went on to do some applications for copper, and we were successful in that. So next work was actually nickel. So I thought that nickel actually, there are a lot of literature references wherein people have used nickel oxides and nickel for energy applications. But there is no reference to aerogels of nickels being used for energy. So that actually motivated me to start nickel aerogels in the first case. And regarding the volumetric capacitance, I will take that into consideration, Professor, and I will try to do it in the future. Thank you so much.
I think in your materials, so you made nickel and nickel oxide composite structure. I think nickel oxide contribute the total capacitance, and the nickel can provide some electron pathway. So have you measured the ratio between the nickel and nickel oxide in your sample?
Not yet, Professor.
Yeah, I think if you control the heat treatment condition, then you can control both contents and you can optimize the material.
Sure, Professor. In the literature, we found that the nickel oxide activity was at the high, around 400 and 450. So we annealed straight away to 400 because sometimes the aerogels, the structure can actually disintegrate when we anneal at very high temperatures. So that is why we chose a moderate temperature and then we studied, but I will take it into consideration. Thank you so much.
네, 그럼 여기서 마치도록 하겠습니다.